So you're at home and you're hungry, so you decide to make a batch of cookies. And in order to make this cookie, you have a recipe. And in order to make cookies, or actually you are going to make 1 dozen cookies, so 12 cookies. You need 3 eggs plus 4 cups of flour. And notice I kind of wrote this recipe like a chemical reaction. 3 eggs plus 4 cups of flour plus obviously some other stuff gives us 12 cookies. So you go to your refrigerator and you see that you have 6 eggs and 5 cups of flour. Well, how many cookies can you make? Well, you can look and you say, well, if you have 6 eggs, and each batch of 12 cookies requires 3 eggs, you could make a total of 24 cookies. With the 5 cups of flour, well, you need 4 cups to make 12 cookies, and we don't have enough cups to make 24 cookies, so we can only make 12. So 5 cups of flour is only enough to make 12 cookies with 1 cup of flour remaining, and 6 eggs is enough to make 24 cookies. Well, how many cookies are you going to make? Well, the answer is you can only make 12 cookies. The flour is limiting. We actually call this the limiting reactant. And in the case of this recipe, the limiting reactant runs out first. So we run out of the flour before we run out of the eggs. Even though we have more eggs than we need, we can actually make 24 cookies from those eggs. We run out of flour first, so we can't make more than 12 cookies. What we have extra of is called the excess reactant. And this is what you have left over, or extra. So how does this relate to chemistry? Well, chemistry and cooking are pretty much the same thing. Put a bunch of ingredients, reactants together, and you get a rearranged version of those reactants, and you get your product. And in this process, there are actually several chemical reactions. But let's look at a limiting reactant problem in terms of one actual chemical reaction. Let's say that you have 3 moles of magnesium and 5 moles of nitrogen, and you want to know how much magnesium nitride you can produce. Well, we need to see which reactant, the magnesium or the nitrogen, is going to run out first. Which one will be the limiting reactant? So the first step is to balance the chemical equation. We can't solve these problems just like the stoichiometry problems we've done before. We can't start them until we've balanced the chemical equation. And all we need to do to balance this equation is we need 3 magnesiums, and then everything else balances. Once we have that, we need to see how much product we can make given each of the reactants. So if we have 3 moles of magnesium, we need to know how much magnesium nitride will be produced. And then we have to see, well, if we have 5 moles of nitrogen, how many moles of product? So the second step, convert each given into moles or grams of product. And moles or grams will depend on what the problem is asking. In this case, we're looking for moles. So let's do that. We'll start with magnesium. 3 moles. Magnesium over 1 times mole of magnesium on the bottom. And then because we need to convert to a new compound, we convert moles to moles. Moles of magnesium nitride. Units cancel, we're left with moles of magnesium nitride, and the ratio is 3 magnesiums to 1 magnesium nitride. Solve that, and you get 1 mole of magnesium nitride. So starting with 3 moles of magnesium, we get 1 mole of magnesium nitride. Now what if we had enough to react with 5 moles of nitrogen? So we'll start with 5 moles of nitrogen over 1 times mole nitrogen on the bottom, and then we're looking for moles magnesium nitride. And the numbers here are 1 and 1, and we calculate this to be 5 moles of magnesium nitride. Well, which one are we going to make? Are we going to make 5 moles, or are we going to make 1 mole of product? Well, the answer is the low answer is going to be the amount you make. So 3, the lowest amount of product is how much will be produced in the reaction. And think back to the cookie recipe. The number of cookies we could make were limited by whichever reactant, whichever ingredient made less cookies. In this case, the reactant that makes fewer products is the magnesium. And because this magnesium runs out after we make 1 mole of magnesium nitride, we cannot make more than that, even though we have enough nitrogen to make up to 5 moles. There's not enough magnesium, so the reaction stops. And because the magnesium controls how much product is made, the magnesium will be the limiting reactant. The magnesium limits how much product can be made. And the nitrogen, because we have extra nitrogen left over, we have more than what's going to react, because once magnesium is used up, no more nitrogen can react with it. This is our excess reactant. So the limiting reactant is the reactant that runs out first, stopping the reaction, and it produces the smallest amount of product. The excess reactant is the reactant that remains in some amount after the reaction stops, since there is no more of the other reactant to react with it. And this is the reactant that produces the highest or the higher amount of product. One common mistake that is often made is saying that, well, this is the limiting reactant, or this is the excess reactant. Before you say what's limiting and excess, remember that these are reactants. If you say this is a limiting reactant, well, magnesium nitride is a product, so there's no way it could be a limiting reactant or excess reactant. We have to look at the original starting compounds, and those will either be limiting or excess. So magnesium and nitrogen can be the limiting and excess reactants. Since this is a product, it cannot be so. A more common question that can be asked is, if you're given a certain mass of magnesium and a certain mass of nitrogen, how much magnesium nitride, how many grams of magnesium nitride can be produced? And this is more common because if you were asked to find a certain amount of reactant, you would probably find its mass. So we're going to follow the exact same steps. So the equation is already balanced. But now, instead of converting each into moles of product, I'm going to convert them to grams of product. So we start with the 36 grams of magnesium. Over 1 times grams magnesium, convert to moles of magnesium. Then the next fraction, mole magnesium to mole magnesium nitride. And then the last added step is we have to go moles magnesium nitride to grams of magnesium nitride. Cancel out the units. We're left with grams of magnesium nitride. So the molar mass of magnesium, we have 1 mole is 24.3 grams. And the molar ratio is 1 mole of magnesium nitride to 3 moles of magnesium. And then we have the molar mass of magnesium nitride. So 1 mole of magnesium nitride is 100.9 grams. So we solve this and get 49.8 grams of magnesium nitride. So now we do the exact same thing, but starting with the other given. So when we do out the same math for grams of nitrogen, we see that we make 90 grams of magnesium nitride. As with the problem we had before, the lower amount is what we actually made, meaning that the magnesium is limiting because that is the reactant that gave us the lower amount, and the nitrogen is excess.